Hi everyone, my name is Kevin and I'm starting this YouTube series to talk about a project I've been working on called the Spider. This is a box I've been working on for a friend who wanted to add an instrument among this gear of analog synths to be able to get more variety of sounds during his live play. He is in several bands and he plays keyboard and analog synths in general. But he wanted to have more control over his sound. Typically having low frequency oscillators and envelopes that can modulate the sound in real time without himself having to control every knob all the time and replacing the oscillators by knobs that you turn all the time like this. It would be annoying. So instead, this box is generating signals that are sent to the Moog and that allow to modulate the parameters of his choice. So, as example, you can modulate the pitch, the filter cutoff, and a couple of other parameters. I'm going to give you a demo. But first, what is this box about? So, it has 4 channels, and each of them generates a signal. So, they are independent, but at the same time, they are linked together through synchronization with the tempo. So it allows to get a lot of variety, but keeping everything in control during live play. Here is a Moog Slim Fatty of my friend. It's an analog synthesizer that has 2 oscillators, a filter, an envelope, and modulation. It generates pretty fat sounds that are very nice for this good old analog sound. And we can modulate parameters in real time just by turning the knobs. But that would be great if we could do more than this. So for example, we can extend using additional pedals like this one. It's a ring modulator. And this one also allows to have variable amount of filtering. Here is the Spider. As you can see, it's a work in progress, and we can see that the front panel has paper all around it. It's just for preview, but at least we know what it's going to look like almost at the end. And it allows us to change a little bit the layout if we want. On the top left, we can see the screen that shows what's the current configuration with navigation button, tap tempo to change the tempo. We have a column of master controls which are here to change global parameters such as gain to control the volume of every other channels. Then we have 4 channels that have their own set of controls. We have on-off at the bottom, 5 parameters and 3 switches, with the top one allowing to change the mode with a colored LED showing what mode we are on. Now if we look at the back, we can see from the right the power here with the main power supply switch, MIDI in, through and out that are used typically for the envelope. Then we have 4 symmetrical outputs that go to the synthesizer. Those are symmetrical, meaning that they go to the negative and positive, which is useful for pitch, for example. Then we have 4 outputs that are non-symmetrical. They go from 0 to 5 volts, and they allow to control parameters such as filter cutoff. Here we have a pedal input for the tap tempo, in case we don't want to use the hand in front, and this is MIDI panic, in case something goes wrong with the keyboard. Now, if we have a look inside, it opens this way. We can see that a lot is going on here, but at the same time, it's made of modules, so not very complex to understand. So on the left here we have the user interface and the screen, the general controls, the 4 independent channels, the connectors on the back we saw just before, and then we have the motherboard here. On the top left we can see the power supply here. Then we have the user interface controller here, it's an Arduino Mega, and it drives the screen and all the knobs here. Then we have the second Arduino here, which generates the signals digitally, and we have the digital to analog conversion stage, which is in this area here. And that part here at the bottom is for multiplexing the knobs, to have lots of knobs with just a few inputs on the board. And now if we look completely under, we can see in this area here that the digital to analog conversion. We have the digital to analog converters at the top here, those chips, and then we have op-amps here to scale and bias the output to have a really precise output when we directly connect to the synthesizer. Time for a little demo. Here I've plugged the spider onto my oscilloscope so we can see what's happening on the output. Channel 1 is yellow and channel 2 is purple, and yellow is plugged on the input of the synthesizer to control the pitch, and purple is controlling the ring modulator, the amount of mix between the filtered and non-filtered sound. We can see for the moment everything is constant signal, and on channel 1 let me increase the amplitude. We can see that now I have a signal on the output which is a sine wave. It's a low frequency sine wave, so that's why it's called a low frequency oscillator. And this one matches the tempo which is 132 beats per minute. And I can change the shape of the signal from sine wave to triangle wave, square wave, sawtooth up, and sawtooth down. The second channel works independently but is still synchronized. So here, if I increase progressively, we can see that I have a different signal, different amplitude, but they are in sync. So if I use sine wave, we can see they are exact. But I have a control on the second channel. Here, for example, I increase the frequency, which is 4 times the frequency of the signal above. But if I come back to the original frequency, they are perfectly synchronized. Let's see what it sounds like. So here is a note without modulation. And now let's update the pitch. So here I purposely took an extreme example so we can really hear what's happening. And let's play with some of the parameters. Now the frequency. And now back to the original sound. Let's try the second channel, which is on the ring modulator. And both of them at the same time. Let's have a quick look at the user interface. So when I turn on, we have a little animation that shows us then the main screen. This main screen has the same layout as the rest of the spider. So we have the master controls on the left with 4 channels, and here we have the control of the tempo at the top. If I use the navigation key, I can go between the different screens and have for the moment also a couple of debug screens I'm going to show quickly. So here we have, for each parameter, for example here we have the amplitude, and I can change in real time like this. We can see the value, what it means, so in that case it's the gain, and I can do this for each channel independently. Then we have, for example here, I will have later something that shows the shape of the signal we are generating, but for the moment it's missing, it's a work in progress. We then have here the offset, which is a positive or negative number. It allows me to choose how asymmetrical I am. Then we have WF, which is a waveform. We have sine, triangle, square, sawtooth up and sawtooth down. We have then the multiplier for the frequency, which is 1/8 of the tempo, 1/4, 1/4, 1 second, 1, 2, 4, and I can also use the multiplier to go further. So here we have 64 times faster than the tempo. And here we have the phase, which allows to move horizontally the waveform relatively to the tempo, and have the same control for each channel. That is the overview page, and we can see here it shows me that I'm on the page with a 4 that says it shows the 4 channels simultaneously. I can then show A, B, C, D, which is a detail of each of the 4 channels, and P is for the preferences page. So here I'm on channel A, and right now I have a sine wave, as we saw earlier, which doesn't have the full gain. So if I put the full gain, I will have it this way. On the left we see the general controls, and on the right the controls of channel A. So I have a real-time update of the content of the screen. Here I'm changing the offset, and we can even see the clamping at the bottom and at the top. The area at the top which is missing here will have some of the flags or the state of the channels, for example on off, or different configuration we can do with the switches. And we can see that here change of shape, still, amplitude, offset, and even phase. So we can see I'm changing horizontally where it is. The vertical bar on the left represents the bit associated with the tempo. So we have the same for channel 2, B, for channel C and D. And then here we have the preferences page that stores the data into the internal memory. So when we turn it back on, we get those parameters back. We can change settings about the screen, for example invert the colors of the entire user interface, change the contrast, and then we have some parameter for MIDI, like that say which channel to use. And then have a little Easter egg, which is a 3D rendering of the logo, but this 3D rendering is done using only a 8-bit microcontroller, which runs at 16 MHz, so it was a challenge to make it run at this speed. And then I have a couple of debug screens. So do not pay attention to channel C and D. Right now they are not connected, so they are showing some noise, but the 2 left channels here are showing, for example, the values of the knobs. So here we are at 664. It goes up to a bit higher than 1000, and then goes down to 0. So it's good for debugging. And if I change the switches, we can see their state, or which mode I am in at the top, or if the channel is on and off at the bottom. The next screen here is For the communication between the two microcontrollers, the user interface and the signal generator, they are exchanging messages through serial communication, and that allows me to see what's happening. So here I'm changing the phase for the channel A, and those are the values that are used. Then here I'm changing the gain, changing the waveform. And if I change the gain of the general gain, it needs to update the gain of all the channels simultaneously. So here it's sending a lot of messages to update all the channels. So we see here A and B, because C and D are not wired yet. And now we are back to the main screen. I hope you enjoyed this introduction video to the Spider project. I will post soon different videos that will show the different modules of the Spider. I will talk about the electronics and how the different modules work together. You can find an extra video we made a few weeks back. It is on my friend's YouTube channel. You can find the link below. And I hope to see you for the next video. Thanks for watching. Stay tuned.